NumPy also provides a large number of mathematical functions. They are called universal functions, or a func, and are fundamental objects in NumPy. These functions operate element-wise on any given array and create another array as the output. There are numerous other mathematical functions also available in NumPy, such as average, cell, dot, floor, inner, and inverse. Let's look at some common func examples. The shape of a basic array can be changed according to the requirement using NumPy library functions. These array shape manipulation methods really come in handy during the data wrangling phase and is used extensively by data scientists. Following are some common methods for manipulating shapes: flatten, resize, reshape, stack, split. Let's look at each in the following screens. This code snippet shows you how the shape of the same dataset keeps on changing by using different shape manipulation techniques and methods. 1. The ravel function flattens the dataset into a single row. 2. Reshape is a function which reshapes the dataset. Here the dataset is reshaped to 3 rows and 4 columns. 3. The next code resizes the dataset back to its original dimensions, which is 2 by 6. 4. The hsplit function then splits the array into 2. Both the arrays now contain 2 rows and 3 columns. 5. Finally, at the bottom, it shows how to stack the 2 arrays together. NumPy uses broadcasting to carry out arithmetic operations between arrays of different shapes. To understand how this works, let's look at the examples shown here. Array A and Array B have the same shape, which is 1 row and 4 columns. So, to calculate the product of the 2 arrays, NumPy conducts an element-wise manipulation. However, scalar C is a single scalar value. Its shape doesn't match with Array A. In this case, NumPy doesn't have to create copies of the scalar value to multiply it element-wise with the array elements. Instead, it broadcasts the scalar value over the entire array to find the product. This saves memory space, as an array takes a lot more memory than a scalar. However, broadcasting does have its own limitations. It's subject to certain constraints as listed here. When NumPy operates on 2 arrays, it compares their shapes element-wise. It finds these shapes compatible only if their dimensions are the same, or one of them has a dimension of size 1. If these conditions are not met, a value error is thrown, indicating that the arrays have incompatible shapes. Let's look at an example to see how broadcasting works. The 2 datasets represent a worker's earnings over a period of 2 weeks, excluding weekends. The total earning after 2 weeks is the vector addition, where element-wise arithmetic operation is performed. To calculate the number of hours worked for each day in week 1, you need to divide the week 1 dataset by 15, which is the hourly wage. This arithmetic operation is carried out through broadcasting. Transpose is one of the linear algebra methods used by data scientists. It helps them fix problems in the data. For example, let's take a test scenario. The number of candidates who took the tests are 2, and the number of tests conducted are 4. Now, the way the data is represented here looks like 4 candidates took 2 tests. Therefore, it's evident that the data is provided on opposite axes. And by flipping the positions while keeping the data intact, we can solve the problem. To do this, we can use the transpose function. These are some other examples of linear algebra functions. Inverse is method to inverse the arrays and can be applied to only square matrices, that is 2 by 2 or 3 by 3. Trace is another method which helps you perform sum on the diagonal data elements of the array. Note that trace is used for only diagonals. It's in incremental order and is applied only from left to right and not vice versa. Sum will give you sum of entire data elements. Given a data set of a few countries and their GDPs, let's see how you can use NumPy to find the country with the highest GDP and the one with the lowest GDP. You can also print a given text iteratively for the entire list of countries and their GDPs. You can find the highest GDP value, the lowest GDP value, the mean GDP, the standardized GDP value, and the sum of all GDPs.